Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the points of intersection between a line and a parabola. So when you have a line and parabola, they may intersect 0 times, 1 time, or twice. That's because we're going to end up solving a quadratic, and a quadratic always has 0, 1, or 2 solutions. Now, if the line and the parabola intersect once, we say the line is a tangent. If they intersect twice, we call it a secant. All right, let's start with this example here. We're going to calculate the points of intersection of this line and this parabola. So basically, we want to find a point that this line goes through and this parabola also goes through. So they'll have the same x and y values. So all we need to do is equate the two. Let this equal this. So we now have a quadratic equation to solve. You should know by now, to solve a quadratic, we need to have one side equal to 0. So we're going to subtract 3x and add 5 to both sides. Now this is a non-monic quadratic trinomial because there are 3 terms and the leading coefficient is 2. So we could use quadratic formula or completing the square. I'm going to solve this using factorization. So to factorize this, we need to use the AC method. So a times c, 2 times 12 is equal to 24. We need to find two numbers that multiply to 24 and add to negative 11. Those numbers are, of course, negative 8 and negative 3, so we're going to split up the middle term. Doesn't matter the order, whether you put the negative 3 or the negative 8 first. And then we're going to factorize the first two using the highest common factor method. And then we're going to factorize the next two using the highest common factor method. So now we sort of have two terms. This is like a term, this is a term. X minus 4 is common to both terms, so we write that out the front, and what's left is just written in the second bracket. So now we can use the null factor law. If the first bracket equals 0, we get x equals 4. If the second bracket is equal to 0, x equals 3 on 2. Now we're not quite done yet because we needed to find the points. So when you're asked to find a point, you need an x value and a y value. It's going to be much easier to find the y value by substituting each of these x values into this equation here. So when x equals 4, y is 3 times 4 minus 5, which is 7. When x is 3 over 2, which is 1.5, y is negative 0.5. So they are the 2 points of intersection. All right, let's look at one more example. So this time, rather than finding the points of intersection, we're asked to find this value here. So this line is a tangent to this parabola. So remember I said in the previous slide, this line will be a tangent if it intersects with this parabola once and only once. So if I wanted to find the point of intersection, I would just equate the two exactly like I did on the previous slide. So I have quadratic equals line. So of course I want one side to equal 0, so I'm going to need to add 3x and subtract 1 from both sides. So this line is a tangent to this parabola if this equation has only one solution. And we know from previous videos it will have only one solution if b squared minus 4 times a times c is equal to 0. Remember, one solution to a quadratic means that the discriminant is equal to 0. So we get 64 minus 4k plus 4 is equal to 0. Solving this equation, we get k is equal to 17. So it turns out if k is 17, these two graphs will intersect at the point negative 4, 13. There will only be one point of intersection, so the line is a tangent. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.